it wasn't working, but when we reduced the number of cities, we saw that it actually was
Okay.
working.
Yeah. Okay, so ladies and gentlemen, while the models were being debugged, I actually led a few other people whose models were working well through a couple exercises. One of the things we did is we renamed the basic thing as baseline, and that is all the standard parameters. You'll notice that none of these are highlighted, okay? And then we created a few additional scenarios which to explore other things. Now, what I did is I created new experiments for each of these new scenarios. So, there might be a scenario, short latency, very high mobility. And here we're going to have a duration of latency of 3 days rather than 3 weeks. So we shorten it by a factor of 7, but we will have a migration rate of 1 per year. And you'll notice when I do this, it highlights for me the things that I have modified. Oh my gosh, look at that. It failed to modify that. It failed to indicate that this one is modified. It's probably because it was an expression originally. It originally was this, and then I modified it.
No, I think maybe if you click out of there and click back into it, it'll do it.
No.
Oh, really?
No. Yeah. So, but it highlighted duration of latency here as one of the things. And that's a very nice feature of AnyLogic, that generally it indicates when you modify one of the default assumptions. Okay. So that's one way to do that. The problem with doing that is you really have to go down and remember to frob the settings to their appropriate values. So in this case, for example, we need to change it back to random seed. We need to change it to random seed. Okay. Now, the other way that Tom had suggested is actually my normal operating procedure, which is typically I'll go to baseline, I'll leave the parameters in the normal values, but I'll often adjust other aspects of the model operation. For example, how long the model runs, whether to stop it at a specified time, for example, or whether to run it, on an ongoing basis. And then I will, and I'll often set it so it's a random seed, and then I'll copy this baseline. I'll do copy, and then I'll go up here and I'll do paste. And here, copy here, and then I'll go up here and I'll do paste. And that will allow me to sort of make duplicates of the baseline that preserve all these other characteristics. There's a lot in here, including the size and width of the window, which things are shown on the menu bars or what have you, and things about how long it runs, things about the parameter assumptions. So sometimes you want to copy a lot from the baseline. Okay. In any case, we explored a couple different scenarios, and one of the things that was observed is that the persistence of infection is not guaranteed. In fact, some runs it dies out sooner than others. In general, the more cities that you have, the more likely it will persist, because the infection can diffuse among more cities. But sometimes it will die out. The longer the latency of the infection, or at least if you start shortening the latency, it will tend to die out. So I'm going to create, for example, this one. I just copied this, and I'll do medium latency, and I will shorten the latency of infection from 2 weeks to, let's say, 1.5 weeks. Okay, and if I run that, the chance that it will die out is somewhat higher, or it will often die out sooner than in the original model. It spreads. Why is it spreading between cities? Can anyone tell me? It's migration. People bring the infection. In fact, you can see them. Some of the people, if you start looking as the infection is spreading, you'll see the occasional person moving over to another city and bringing the infection with them. Okay, but many of those people who go over to another city have the infection die out in them before in fact it catches hold. Migration is another big factor, and for migration, the more migration you have, the quicker it will disseminate. It's like sparks from a fire. So very high mobility of like one per year with a longer duration will tend to lead to very fulsome spreading. So, we can do experiments with a model like this. We could also do experiments for what will be needed to snuff it out in terms of changing behavioral factors. In general, you can experiment rather readily with different experiments without, in fact, changing the model itself. A lot of assumptions can be run, and they're run because we have large numbers of parameters that are in fact in main, and therefore we can change them very readily. So high amounts of migration can lead to a very ready dissemination of infection between these cities. It still is dependent on the initial person getting infected. Occasionally you'll find it not spreading because the initial person doesn't get infected, it doesn't catch, in which case it's not going to spread very far. Okay, so that's that little hierarchical model. I guess a couple words here. If we were to want to take a look at the prevalence of infection across cities, how would we do that? Suppose we want to have something that calculates the prevalence of infection on a per city basis. Where would we go? We go to stats. Would we do it in Maine if we want to be on a per city basis? Okay, so let's go to city. And I want to show you how you do prevalence, a fractional prevalence, because it's not immediately obvious. Okay? So let's go to city, and we'll go to the city population. That's where statistics live, right? And for the city population, we're going to create a statistic, okay? Okay. Okay, now my AnyLogic is very slow here. Okay, I opened something up. I think that's why. Hey, what's going on? Sorry, something is happening here. I don't understand. Okay. Okay, I don't understand what I'm being asked to do here. Okay, bad things are happening. Okay, hopefully they're not happening on your computer as well.